So very quickly, I want to explain what BCF is in a nutshell, and Kyle touched upon this one big switch analogy. So traditional chassis pair, you have a pair of supervisors, you have line cards where you attach things, and you have the fabric backplane. Everybody knows this. So what is BCF in a nutshell? It is actually one big switch, right? So we have a pair of controllers which act as the supervisors. Then we have a set of spine switches, which is the backplane of the network, and then we have a bunch of leaf switches where you attach your workloads, right? And the software running on the switches is Switchlight OS, which is based off of ONL, Open Network Linux. And because we are a software-only company, we don't do the hardware, right? You buy the hardware from Dell, Acton, HP, whoever you want, and then you can put our software on it. The advantage of using this one big switch kind of analogy is that you have a single pane of glass to see your entire network, right? And this helps us manage the entire fabric. You don't need to worry about the individual physical links and ports, things like that. So that's BCF in a nutshell. A regular admin can use BCF in this form, just replace your L2 switches that you have, and you use a fabric instead, and be done with it. But we have gone further, right? So the next step beyond this is to use BCF for hyperconverged networking. So the first step into getting into hyperconverged networking is to integrate with all of these orchestration systems. You have VMware, you have OpenStack, you have containers, and the latest one is Nutanix. So what we've gone and done is built plugins for each of these, right? They integrate with the orchestration system, and then they use the REST API interface to make calls to BCF and program the network. And this gives a very tight coupling between the orchestration system and your network. So what is it that makes BCF an excellent choice for hyperconverged networking? I revert back to the one big switch analogy, right? When you think about it, the orchestration system, all it needs to do is talk to this one pane of glass, one controller, and you get your entire network programmed underneath that by the controller itself. So when you get into that, that makes it really simple for an orchestration system to just make a network call, right, to one place. So that works in our advantage. The other interesting thing is that we have an API first as a design principle, which means as a backend engineer, when I work on the code, I actually do not know if a config change was made by CLI, GUI. It's just a REST API call. And every single config change is designed as a REST API first. And because this is just software sitting on various orchestration systems, it's very easy for them to make that REST API call. And we never have to get into this, oh, it's available in the CLI, it's available in the GUI, but not somewhere else, right? It's always available. So that API first design principle is what makes this happen. The third very interesting problem that we had to solve to get this right is the concept of distributed routing. Every single logical router or router of a VPC is sitting on every single rack in the fabric. It's not at one place. So the beautiful thing about this is that your HCI workload could be sitting on any rack, and they could be related in some way, right? If your Nutanix workload could be spread across 3 racks, but every single workload, every single VM gets the same view of the router when it comes to networking. And that's only possible with distributed routing. And going further, if you want to add another workload or a host or move something around, it makes it simple because you just take it and move it, and you will see the same routing view, right? The IP address will be preserved. It will just move from one place to another. And that is only possible because we solved the challenging distributed routing problem. And your network is not just for the orchestration system. As a network admin, you have a bunch of customers, right? In order to let the orchestration system configure the network in its own way, you need this concept of a VPC. You need a concept of multiple VPCs on top of the same physical network. And these are the 4 key reasons I would think are what make HCI networking possible with BCF. Questions? Okay. When we were designing BCF, back in the day, we were thinking about the main use case as a private cloud. We imagined multiple users using this network, and then there was a system administrator who was controlling who talks to whom at the high level, right? And when a user configured their own little network, they were free to do as they want within their tenant, as we called them, and they have evolved into VPCs now for us. So first up, this slide is slightly off in the animation, but first up, let's say you have a Nutanix instance. Let me just bring up the whole thing. Okay, let's say you have the Nutanix instance. The Nutanix instance has its own workload spread across 2 racks. It's not, you have to somehow isolate this within the Nutanix cluster itself. So the instances that are managed by Nutanix don't necessarily talk to Red Hat or Kubernetes or anyone else, but you have the same physical network. So to get this right, one of the most challenging technical problems was how do you isolate these VPC tenants, right? And you saw that a little bit from when Kyle gave you the access to the network. You were just in another VPC. And because you were in another VPC, you couldn't actually do anything to the other tenants or other VPCs present in the network. So this was the first challenging part. The other part that came along with doing this is managing overlapping IPs and overlapping VLANs. Nutanix hosts might be using VLAN 100. That VLAN externally is being used by Kubernetes. That's entirely possible. Because we are this SDN fabric, we can use that VLAN 100 on port 1 of switch 1 and say that it belongs to the Nutanix VPC, and port 1 switch 2, that same VLAN belongs to somewhere else. So solving that overlapping VLAN and overlapping IP problem was key to getting this right. And then one of the other challenges is how do you control access to shared resources? In your network, you're obviously going to have shared resources for all of these orchestration systems. So to control access, we have this concept of a logical system router, right? We envision managed by the network administrator himself. He's in charge, and he can control, my shared access is in this VPC. This guy can talk to this VPC, but someone else cannot, right? So you have that networking control over shared resources. I would say from the top 8 or 10 challenging problems that we had to solve to get this right, these were the top 3, right? And if you think about it, if you think about doing something like this in the cloud, you would go to Amazon VPC, you'd click networks, you configure networks, you configure routes, policies, etc. You'd never actually interact with the physical network. You can't, right? On-prem, we want to get to that. The only touch point that you have with PCF for physical is if you say my Nutanix VPC, you have to say, this host is hanging off of these switches. You just have to tell us that, right? And then you have to say that this is the VLAN you get, right? So you create a new end host or VM. You have to say it's hanging off of this interface, and you have to give us the location and the VLAN, right? With our orchestration integration, we automate that for you. So Don is going to show you a video where the person, when you create endpoints on Nutanix or move hosts or any of that sort, you are not interacting with the network at all. It's like a cloud, on-prem cloud deployment.
So what you're pitching here is any cloud any on-prem cloud.
Yeah.
So whether I'm using OpenShift or Kubernetes,
yes,
or
they're all on the same physical fabric.
Whatever vCloud it's called this week,
yes,
vRealize.
Yes.
I can still have one unified physical fabric underneath.
That's
You're
correct.
presenting something to them that makes it look like the network is there for them.
Yes.
Right.
Absolutely. And they're isolated, right? That's the key point.
Right.
Right.
So the OpenShift sits in this VPC
yes,
construct,
yes,
that it thinks it's completely on its own network.
That's correct.
But it's actually on a shared physical infrastructure. So you
absolutely
can have, these 2 physical servers here are Kubernetes, those 2 servers here are Kubernetes. Yep. I don't need to go and buy 9 racks of Nutanix and then try and weld a Kubernetes on top
right,
of that stuff.
Right. And better, you have 3 racks and you wanted to add more hosts for Nutanix, you add it on the 4th rack. And because we can scale up to 4 racks, we can scale up to 128
Nutanix
racks.
doesn't ship physical switches with their...
Right, but the boxes, right? You could, the servers. You could put a new server and put a AHV on them, right?
Yeah.
And most importantly, the work that you have to do for a 1 rack is exactly the same for the 50 racks. It doesn't matter. 2 racks, the work that you do to build up a 2 rack system is pretty much the same as 50 rack.
Oh, it's the old story. Solve a problem once, you've solved it 1,000 times. In networking, once you've solved it once. Yeah. Which is what I like. I mean, that's the value prop to me, is I could put a big switch fabric in, and then it doesn't really matter which way the sysadmins go, if you like. Just to sort of denigrate sysadmins for a while. I can support whatever networking strategy I need to support them without having to panic about it. More importantly, I can isolate the sysadmin.
That's the key.
Right? So he thinks he's got an entire network all on his own. He's got his own IP address space.
Make him believe so, yeah.
So...
Yeah.
And you can delegate that to him to configure.
Exactly.
So
and you can troubleshoot if you wanted to, right? You get that visibility.
You want him to do that.
Sure.
Just give him his own space, so that as long as he's not blowing up someone else's space, which is the reason that we normally troubleshoot for them, is because they're going to stand on,
because we don't want them to take everything else down.
We don't want the Kubernetes taking down the mainframe stack. Right. So the isolation is the issue, the microsegmentation. So this is a microsegmentation strategy.
Yeah. Well, a tenancy. It's actually
a multi-tenancy strategy, not a microsegmentation strategy.
Yeah, it's a tenancy strategy. But can you have a common VPC? So for shared services, common layer 3 out, things like that.
Absolutely.
The question then is who is managing that, and I'd expect the network admin to be doing it. But
everyone expects the network admin to be doing it. Just say.
And there is a correlation with cloud. In cloud, there is a shared service VPC, which is now called transit VPC, that is emerging, where all the VPCs would connect to transit VPC for shared services. That's exactly the model we have here as well. So you could create, and that's why we are so excited about having VPCs on-prem, because each VPC is a tenant. Each VPC, so it's not just about multi-tenancy, but it's about multi-orchestration, because each VPC can have its own orchestrator integration. And with that orchestrator integration, as you will see in the demo, you get full network automation within the VPC, full endpoint visibility. All of that comes as part and parcel of the definition of an on-prem VPC.
So we've talked about the demo enough. Let Don take it away with the demo itself.
Thank you, Sudeep. So in the next 10 minutes or 15 minutes, I'm going to walk you through how exactly we're getting things done on the big cloud fabric with respect to this Nutanix AHV hyperconverged environment, right? If you look at like hyperconvergence, enterprise do really adore these things, because it really gives them a very fast path to realizing their enterprise cloud visions, right? But if you take a look at like Nutanix AHV, the whole virtualization, compute, storage, everything gets really stacked really nice into this hyperconverged bundle. But only thing obviously missing is the network itself. And abstracting the all these stacks out, if you look at the public clouds, networking, you can kind of imagine it's already abstracted out along with all the other components, right? If you want to do something on the AWS, what you have to do is, you would create a VPC. For example, you go here, you create a VPC right away. All you need to do is just give a name, and pick out the default parameters. Couple clicks, you're right on the VPC, and you can get the connectivity done. And if you want to add an endpoint to that, you go to the EC2 and bind a particular machine. Pick out a flavor of the image. You can bind a machine to that VPC right away. And you have the compute and everything along with the networking. You really didn't think about these things as a different fundamental units. You can connect to this instance right away. You have both the layer 2 and layer 3 networking done right away. So coming back to the enterprise clouds, especially for the Nutanix environment, right? The only thing missing is the networking itself. And network pulls these environments down. And that's where the big cloud fabric comes and help you out. And I'm going to show you how we're doing it, right? So what I have is I already have a big cloud fabric set up here, a 3-rack topology, normal leaf spine fabric architecture. What I'm going to do is I'm going to bring 3 Nutanix cluster nodes over here. I obviously have to, physically rack them. There's no way out of it, You have to touch these switches and servers because you are on enterprise. You have to physically connect them, but that's the only time that you're going to deal with these physical servers and switches. once the environment is up and running, Big Cloud Fabric can help these environments to build out these AHV clusters. The Prism will come and start controlling these Nutanix AHV nodes, and the Big Cloud Fabric can automatically detect wherever these AHV nodes are. Doesn't matter, doesn't matter where you connected these guys, we can automatically pick those out. Then the next thing that we are going to do very differently is for the whole AHV cluster, we can start automating VPC tenants out of it. And we can give customizable ability to the user to actually build out, whether to create one VPC or multiple shared ones that if they want.
I'm really excited about that because I have a DevOps infrastructure where somebody CI/CDs and then spins up a Kubernetes cluster, or a Nutanix, a vSAN, or the whole system, deploy it, and you're automatically saying the fabric will go. So I can boot them from an Oni or a Pixie boot, and then everything's done. All right, the servers come up, I run my tests against them, I tear them down, they go back into the pool.
Absolutely.
And they would go to a dynamic VPC.
Absolutely.
So I'm actually bare metaling. I've actually just built a bare metal cloud.
Yep.
Effectively.
Yep.
That's the whole point.
Yep.
With
And multiple of our customers actually doing that as well.
Okay.
Yeah.
Right.
Amazon networking on-premise.
I am. I am, because I didn't think any of the vendors had considered this idea. I've seen every other vendor literally try and map their idea onto Amazon,
Right.
or Azure.
Right.
And there's sort of like there's a fundamental recognition of the fact that the VPC is a universal, an atomic element of networking. So instead of thinking of the VLAN and trying to map a VPC to a VLAN construct or an IP subnet construct, we're actually just saying take the VPC concept and map it back into the private cloud, right? So that's an embrace of, to me, that's an embrace of what made public cloud. AWS proved the concept of the VPC is viable and it works. I just hadn't had my mind spun 180 degrees to see that. So yes, I'm shocked by that, yes.
We figured, look, imitation is the most sincere form of flattery.
Yep.
We think the Amazon team should be extremely flattered.
Yeah. More importantly, what AWS has done with the VPC is proven that that model works.
Yeah.
For consumption, for security, for operations, for DevOps, for sysadmins to cope with it, right? It's a universal notion of networking. And it's a recognition that that actually works. I mean, yeah, we've always, our idea of solving that problem is to say, we'll give you dynamic DNS and DDA integrated with DHCP. Yay us. Do you know what I mean? Like, to me, it's that, yeah. It's just that's what works. Let's just go and use it. So, yeah. Hadn't thought about it that way, though, up until now. Yeah. You caught me flat-footed again. It was OpenFlow in 2011.
It's hard to stay one step ahead of you, man. I mean, we're working hard at it.
Yeah, so moving on, the third thing that I'm going to show is the distributed routing that Sudeep mentioned. I can bring up a new VLAN or a new VM and try to show you guys how easy it is to get the routing done on the Big Cloud Fabric itself. And nothing but the least, the VPC is not just about the networking concept. It's about the troubleshooting, analytics, and all these things. And we pull them into that VPC as well. And I'll quickly show you a little bit more around that as well. So moving on, let's go ahead and log into the Big Cloud Fabric itself. So this is the landing page right here that you freely explore during the last 2 hours. And when you go into this Fabric view right here, this is where we group all our physical components, whether it's the switches, interfaces, all these things. You will get a quick overview of the Fabric page. And if I go into the interface groups, there are no Nutanix node right here because these Nutanix nodes are right now is just physically connected. Nothing is doing that. And if I go into the VPC tenant, you will see there are no tenants either. Right? And if I log into the Prism, and this is that single pane of glass that Nutanix gives you to the whole AHV infrastructure. I have 3 hosts right here. If I go into the VM, I have 2 web VMs, and those belong into the 103.subnet right here. And obviously, if I right-click on it, open up the console, try to ping the other guy, the ping would not go through because network is not set up yet, right? It's just physically connected right now. Now, all you need to do is to get everything going in that L2 level. All you need to do is create that Nutanix Prism on the BCF. And this is the only configuration item that you will do for whether it's a 2-rack Nutanix cluster or a 100-rack Nutanix cluster. And this is where you get that chance to map your Nutanix AHV to a different VPC tenants. We have spent a lot of time actually envisioning this and building this. Same way for the VMware as well as for the Nutanix. This particular screen, we've spent so much of our energy trying to nail down this workflow. And we've pretty much, boil it down to literally a single clicks right here. In this case, you will get to map the whole environment to a single VPC, to get automatically mapped, or you get the customizable ability to map it to multiple VPCs. Just for the demo, I'll just map to one VPC tenant called NTN Next right here. And as soon as I hit next, we will start talking to the Prism, get all the things, and start getting connected. If I go back to the interface groups, you will see all the Nutanix nodes got automatically discovered. And along that process, we would create MLAGs. We would detect what the load balancing modes of those nodes. All these are mundane details. We really don't care about it. As long as those settings are correct, we will obey them. We'll automatically correct them and detect them. And furthermore, if there's a problem, we will actually notify the user as well. And this doesn't matter, whether you are connecting to a particular rack or not. You don't really need to do those kind of bookkeeping. Now, obviously, the traffic will start working. And I can drill you down on a little bit more on how exactly this connectivity is going when we move along. And if I go back to the Nutanix Prism, now I get a chance to actually drill down into this whole AHV environment. You will be able to see a lot of details. You'll be able to drill down to, let's say, Nutanix 3 host right here. You'll be able to see the whole OVS networking environment of that particular AHV host. This is very powerful from different angles, right? And there are a lot of different information presented to tackle very different troubleshooting use cases. For example, you can drill into a Nutanix 2 host, see exactly where things are connected, or if not connected.
The Nutanix, if there's a Nutanix operator, he's off in the Nutanix console seeing the network construct from the Nutanix point of view.
Yes. Yeah.
And completely in isolation, can't see anything.
Yes.
But I'm down here as the network administrator with the all-seeing eye.
Yeah.
Yes.
And I'm seeing the Nutanix and the Kubernetes and the Redshift and the blah, blah.
In this case, you're getting a lot of information from Nutanix. So
Yes. So this is multiple API calls to the Nutanix control to pull the metadata around the networking instance so that you can have context.
Yeah.
Yes.
And so when you talk to the Nutanix person, you're telling him that the host, BR0 on host such and such is is configured correctly, and of course they'll go to their screen and see the same thing. But they're looking at it from the Nutanix, so the data is actually shared.
Exactly.
Yeah. Exactly.
I still can't get over the dynamic VPC stuff though. that's got me.
In the endpoint screens, you can really look into the Nutanix VMs, quickly search for a web VM. That's all you need, right? At the end of the day, if there's a problem with a particular VM, you just need to know, what this VM is doing. Everything is presented in, one table format. You just don't have to deal with all this data lying around, scattered around, right? Now, if I go to that VPC tenant itself, you will see, who are the ones people are talking, and right here, that subnet for the 103, we automatically detected and configured that subnet right here. We automatically detected what are the nodes actually belonging to this subnet. We automatically picked out the VMs belonging to that subnet as well.
All of this is from one config.
Yeah.
Right?
Yeah. So try to recap, right? Just that one configuration that we did, that plus sign right there, right? Everything got automated, VPC tenant mapping and everything. Next thing that I want to show you very quickly is, let's say now I want to bring up an app VM on a, let's say, VLAN 104, right? In a traditional environment, if you want to really get this done right, you have to do a lot of things. Start creating MLAGs, all those things first. Then, start creating routing, right? CVI interfaces across all the switches, OSPF runs, all those things, right? You just need to take care of those things, right? Depending on how big your environment is, right? But in Big Cloud Fabric, it's completely baked into the whole VPC workflow itself. We will create a different segment out of you. We will automatically create those CVI interfaces and program those distributed routing across all the switches and all the racks. That's what I'm going to show you basically. Make sense, guys?
This is where we started in 2011.
Yep.
Seriously, that's back in that sort of time frame. That's what we were doing. Yeah. Just that.
Yeah.
And now this is where we are as time moves on.
Yeah. So like you see right here, this is the CVI interface for that 103 VM. Now, if I go create a new VLAN on the HV, right? Let's log into the HV CLI, and we can quickly create VLAN 104, and you will see how exactly that's getting programmed into the big cloud fabric itself. You can define your default gateway from the HV side. We will pick up that. If you refresh it, we'll pick up that. We'll automatically create that SVI for you. So as a result, if you bring up any VM on this new VLAN, right? I'm bringing up a new VM called app VM right here, and the networking is pretty much automatically provisioned here. You will be able to ping right away to that next VLAN interface because L3 is working and distributed routing is at work right now. So, and then this is all handy dandy, right? This is automation part. What about the visibility part? We have this very cool thing called test path, right? As a VPC admin in the Nutanix environment, if you want to troubleshoot communication between these two guys, or for example, you are the VPC tenant, but you are actually talking to some other guy, right? Troubleshooting, it's not configuration, right? You should be able to kind of, see what containers, what VMs are running. All you need to do is, pick those source and destinations out. We will actually say whether the traffic is getting forwarded or not. It will just right away, it says forwarded. If you want to do a packet level trace, all you need to do is, run a quick fabric trace between these two endpoints, whether it's two Nutanix VMs, Nutanix to a VMware VM, or Nutanix to a Kubernetes container. It will show you exactly how the path looks like, how many packets are getting, whether it's getting dropped, mostly importantly. It will show you exactly what Nutanix bridge that's exiting out of the fabric. So, I know.
So can I ask you something?
Yeah.
Is this a real traffic representation, or is it like a?
No, it's a real traffic representation.
All right.
Yeah. So
you're injecting packets.
Correct. I mean, yeah. So there are two things. In the Kubernetes environment, the controllers actually can inject the packet into the fabric, but in Nutanix and VMware environments, we can actually pinpoint to a particular TCP or UDP traffic flow or ICMP traffic flow and try to catch that traffic flow active on the fabric itself.
Uh-huh.
So
Flow
both
matching.
yeah.
Actually matching open flow records most, or a flow record. Definitely.
Yeah. Yeah.
So one of the powerful things that you get with VPCs is security groups. Any plans for security group functionality?
So, yeah, sure.
So this is one where security group has to be done in the vSwitch. There is no way without breaking a lot of laws of physics or doing something that we see as not terribly engineering-wise to do it any other way. On the enterprise, the nice thing that the big cloud providers have is they have a homogeneous set of vSwitches that they own entirely, and the enterprise environment couldn't be more different. So our strategy there is to play some role in security group configuration, but security group enforcement we would pass through to NSX APIs, to Nutanix APIs, to other APIs. On the container side, we actually provide the vSwitch. It's an option, so we could do the enforcement as well. But we have to be ready for security groups, for enterprise VPCs, for the data plane to be very, very heterogeneous.
Right.
We actually think that given the products out on the market, out of everything that we know, we can actually provide a security groups implementation, but it's not us alone. It's us calling somebody else's API. Seems like the best way to do it.
Yeah.
Yep.
Given the way enterprises work, it might be a practical way.
Yes.
Because the NSX security map looks different to a Kubernetes map.
Yeah.
There is an alternate approach that is investigated in the market of looping every single packet up to the top of rack switch, which seems really silly.
Agreed.
So as you saw, once you create VPCs, the host team, Nutanix, folks who manage Nutanix nodes, they can add a host or nodes at their own pace. You have to do no coordination with networking team. You keep adding hosts, the network automatically recognizes them, puts them in the pool. The VM team can go and create VMs on those Nutanix nodes. VLANs are automatically created. If you're across VLANs, routing is automatically created. You get full visibility, troubles. So this is the new sort of newness of VPC that brings on-premise. And that's really, we think, as Greg, you pointed out, it is the new atomic unit that we should be dealing with because it has a human workflow built into it so that you streamline that, or that there is no workflow. It's really, with this automation, network team is now able to say, I'm going to turn on automation, and I'm going to trust but verify. And all the verification is done in real time right in the controller.